So hello everyone, welcome to helpmath.com. So this time we will do z-test for a proportion p here. Okay, so look at these explanations. So z-test for a proportion is a statistical test for a population proportion p. The z-test can be used to when a binomial distribution is given such that here, so np is bigger than or equal to 5 and the nq also bigger than or equal to 5. So that's the base condition here. So before we are using proportion, so we need to double check whether it is satisfied or not. And the test statistic is the sample proportion p cap, and the standardized test statistic is a z here. Okay, so guideline. So the first step always 45 m times p is bigger than or equal to 5. Also nq is bigger than or equal to 5. So that's the first step all the time. And then now we want to state HO and HA. Okay. And also we found alpha value. And now we are using z. So z equal to p cap minus p over square root p times q over n. So there's a formula here. So we have to remember that. Okay, so now if z is in the rejection region, the reject HO, otherwise fail to reject HO. So this one, so I'm going to explain more details when we draw the normal distribution curve. Okay, and now finally we interpret the decision in the context of the original claim. Okay, then let's look at one example. So example, a research center claimed that less than 20% of internet users in the United States have a wireless network in their home. In a random sample of 100 adults, 15% say they have a wireless network in their home. At R factor 0.01, is there enough evidence to support the researcher's claim? Okay, so look at this question. So what was the first step we have to check? Yes, we need to find out n times p equal to, or bigger than or equal to 5. Also n times q is bigger than or equal to 5. So let's check. So n equal to 100 right here, and then p equal to, so 0.2 from right here, then q equal to 0.8. Makes sense, right? Okay, then now I'm going to check n times p, which is 0.2 times 100 equal to 20, which is bigger than or equal to 5. So far so good. And then now n times q equal to 0.2 times 100. Sorry, this is multiply. Then equal to 80. Oh, sorry. So this is 0.8. 800, so 80, so it's bigger than or equal to 5. So now we can use proportion hypothesis testing. Okay, so now let's set up the HO and HA. Okay, so HO and the HA. So when we look at the sentence here, so less than 20%, so less than means not including equal sign, right? So which means it will be under HA, not HO. Be careful. So you can say proportion is less than 0.2, and that's the claim. Which means P is bigger than or equal to 0.2. That will be our null hypothesis. Okay, then now given alpha equal to 0.01. Okay, then now, so let's find out z value using formula here. So z was, so p cap minus p over square root p times q over square root n, like this, right? Okay, then now, so we need to define what p cap value it represent, so which is this one here. So basically sample proportion that representing p cap. Okay, therefore we can make it 0.15 minus 0.20 over square root p. 0.2 times Q 0.8 and divide by square root 100. No. Oh, sorry, I made one formula mistake here. Yeah, that was weird, right? So just n, so 100. Okay, so if you calculate, then you will get negative 1.25. Okay, then now because we are using z-test, we need to find out corresponding z-score based on this alpha. Okay, so we know alpha equal to 0.01, and then this is a one-tail test. Okay, therefore we are using t-table. Okay, so from here, so one-tail alpha and 0.01. Okay, the sample size bigger than 30, so we just go down to the end, then we get about 2.326 here, right? 2.326. So corresponding z alpha equal to 2.326, but this is the left tail test, so it should be negative here. Okay, therefore when I drew the normal curve here, then negative 2.326, that's our z alpha. Then now our z score equal to negative 1.25, so that is belong to on its right side compared to z alpha here. Okay, so basically the smaller size become HA and the bigger is the HO. So since z is belong to HO, we cannot reject HO. So based on that, we can say fail to reject HO. It means the claim is on HA and then we fail to reject HO. Therefore, the claim answer become there is not enough evidence to support the claim. Okay, so that's the answer for this problem. So it means basically the researcher's claim is not correct. Okay.